All right.
37.
You have to watch here, and you have to look at your horizontal asymptotes. We know in that graph the horizontal asymptote happened to where? That horizontal happened up 3. Okay? But if you're looking at this equation, this 3x minus 5 over x minus 2, how do you look at that and say, oh, the horizontal is going to be a 3?
5 minus 2.
No. Nice try, but no. Sorry. Where do you see a 3?
The 3x.
The 3x.
Yeah.
Okay.
Yeah.
But notice there's also below it, technically, isn't that a 1x?
No.
Okay. And why would 3x and 1x be important terms in this? Yeah. Is x not the highest power of x we see in this problem? Yeah. It turns out horizontal asymptotes are controlled by whatever the highest powered term is in the expression. So you go use the highest powered term, and that will help you find your horizontals. I'm going to have to show you several of these for this to totally make sense, but let me write it out for you in words, then we'll go do it. So you use the highest powered term. You take that. You must have the same power from the numerator and the denominator. And that it's going to take a few examples for you to process that one. But in this problem, if we had already not know that this was at 3, you would have looked at this problem and went, oh, the highest power of x in there is x to the first power. And then you would go, do I have that power of x on the top and the bottom? No, but you take wherever the highest one is. In this case, I have a 3x on the top. I would have a 1x on the bottom. Of course, the x's would cancel, and that would leave me with 3 as my horizontal asymptote. Okay. Because asymptotes are lines, you must write them as lines. So you would actually say, oh, here, this horizontal is the horizontal line at 3. How do you write the equation of a horizontal line?
Y equals.
Thank you. It would be y equals 3. And what would the vertical have been here? X equals 2. That's your vertical. Yeah. So your answers need to always be written as lines. That's important. Okay, now let me throw about 50,000 more examples of this at you.
We only have like 20-some minutes. Yeah, dude. Yeah.
So
Yeah, we have.
it's really hot in here.
Yeah.
Okay, before I have you doing whole problems here, I'm just going to do some more horizontals, okay? So this is just more horizontal practice. It's horizontals are the tricky part. So I'm going to give you just some quick equations, and you guys are going to find the horizontal for me. Okay, if I gave you one like that,
Correct.
actually, let me make that a little more pizzazzy. All right? If I gave you something like that, and I said, tell me where the horizontal asymptote is, what would you look at?
X squared.
You would look for the highest power, and you go, what's the highest power in the whole problem?
X squared.
X squared. I see one in the top and the bottom, so my life is easier. And you would go, oh, I have 3x squared over 2x squared, which means I have what? 3 over 2. It's horizontal, so you would say my asymptote is at y equals 3 halves. Okay. Now, I'm waiting for somebody to say, but what if?
But what if?
What if?
Yeah.
Amazing.
More asymptotes.
Okay, this is more horizontal.
Gotta move that.
Okay, so now what is
Talking about Trinket.
what is the highest power in the problem?
X squared.
X squared. So, okay, on the bottom we're going to take 2x squared. You also have to take x squared from the top.
You don't have it, so 0.
So, bingo. If that is not, you don't have that term up there, then you have 0x squared up there.
You said this was
So if you have an x, technically you have 0x squared in front. So now, what's that reduced to? X squared cancel, and you're getting 0, so your horizontal is at y equals 0. Okay, but somebody should still be going, but what if? Bingo! Exactly. Michael said, but what if it's on the top and not on the bottom?
Yeah. Do that
So now,
Then it's undefined.
yeah.
The whole graph is solid.
Okay, so in this case, I would take 5x squared as my highest, so what do I put on the bottom? 0x squared.
Undefined.
And that's undefined.
Says Shannon.
So what's that say about our horizontal? We can't have any. There is none. It's undefined. So therefore, there is no horizontal in this graph.
So it could just be a crazy graph.
Yeah. Okay, when you start talking graphs of rational expressions like this, fractions, they can go wild and crazy and strange. I am actually not having you, by the way, on your instructions, I am not having you graph these things. I'm only having you find the asymptotes, because these graphs are highly unpredictable, and for you all to plot a graph like this right now, you could figure out where the asymptotes are, but then you would have to just literally put a bunch of these points into the equation and plot points with a t-table.
That's all.
Until you can apply calculus methods to it, I would not teach this to you.
Yeah.
So we are going to find the asymptotes. I am not going to make you figure out the graphs by hand. It's without calculus, it's ridiculous. Your calculators will graph them. That's not the issue. So, actually, yes, I did. I don't remember. Who cares?
Everyone cares. We do, obviously. But not you.
Trust me, you want me to throw you as many examples as I possibly can here.
Do it then.
Alright, so we're going to see if you've got it. Yeah, this is still all. So, here you go. Here is your function. I want you to find me all of the horizontal and vertical asymptotes possible in this graph. Okay, so my question to you would be,
Why?
which one do you want to do first?
Hey.
Let's just do the vertical first.
Okay, I normally do vertical first, but it doesn't really matter. Okay, so what did I tell you about how you find verticals?
Whatever the denominator can't equal.
Well, so what makes it, it makes the denominator equal 0. We're trying to find out where it's undefined at. So you literally have to take the denominator and solve it. And you hope it factors. They should factor. I don't think I gave you any that were quadratic formulas. Okay, so if we factor this, we know it's got to be x and x to make x squared. What numbers do you want to use to make 28?
7 and 4.
7 and 4 make 28.
So.
Now, signs.
Negative on 7.
Positive 4. All right. And so then, when I solve my factors, what will I get? Positive 7 and negative 4. And actually, if you write it like that, haven't you actually written it in the proper form of a vertical line? X equals 7 is your vertical asymptote. So when you solve it and write x equals, you're actually writing it in the proper form. So those would be your verticals. X equals 7, x equals negative 4. All right. Find me the horizontals. What do I do?
The highest power is x squared.
Caleb, what's the highest power of x?
That one?
Yeah.
It's x squared.
It's x squared. So what do I put on top?
Zero.
I would put 0x squared, so therefore it reduces to be, so therefore my horizontal asymptote is what? Not, that's not the equation of it.
Yeah.
Thank you, is y equals 0. You must write them as equations of lines. Okay. Well, you'd think, yeah, that's not bad. That's it, right? I got a couple of wrinkles I could draw you.
Blame Canada. All else fails, blame Canada.
Hey, Canada.
Okay, this looks like a nice normal function.
But it's probably not.
Looks pretty sweet. No big deal. Okay, let's do verticals first. If I do verticals, what am I supposed to do?
Set to 0.
Set the bottom equal to 0. The bottom would factor as,
Here it was.
yeah, x plus 2 and x plus 1. Okay, but, did anybody notice anything special about the top?
Oh. Not mine.
Top also factors, doesn't it?
Yep.
Yeah.
So therefore, I would have what on top?
X minus 2.
And x plus 2.
Yeah.
What would happen?
Cancel out.
Yeah, it cancels out the x plus 2. So here's the question. Negative 2 made the denominator equal 0.
Yeah.
So is it a vertical asymptote or not?
No.
No.
But then it cancels.
Yes.
You're
So-
wrong.
No, it's not an asymptote. But there is
No
something
asymptote.
it's undefined, you're right. It's still undefined there. Okay, so what's another way, in a graph, what happens when it's undefined?
It's a solid graph. Everything's solid.
It is not a solid graph, it has,
If it is mitigated.
if it's undefined, is there a point there?
No.
No. So, no, literally, this graph just has a hole at -2. The graph is drawing and then there's just a hole at one spot.
Old now.
Yeah. Unfortunately, I graphed it on the calculator for you, but it won't show it. You have to zoom in on it so you can see there's a hole there. It doesn't work very well. But it just creates a hole.
There's a hole in There's a hole in the asymptote. That's what she's saying.
Holes happen when your terms cancel. Terms, I should be plural.
Asymptote.
Or, how do I say that? Where the terms cancel, and you have to know where they equal 0.
All we need to know is there's asymptote hole.
So in this case, since x plus 2 cancels, if I actually solve that, this one would have a hole at x equals -2. And literally, the graph draws normal, and there's just a gap at that one spot.
Is it shaded in that one spot?
So, like, if we were drawing it, I actually don't know what this one would look like off the top of my head. But assume, okay, if it was something like a hallway graph, this is some kind of a hallway. I'm just not sure where it's switched without changing forms. It would literally at x,
That's the blood crack graph. You're
at
wrong.
x equals negative.
The top one's the butt crack.
This one is not.
Oh,
So
you're
this
fine.
one would actually, when you got over here to -2, when you set it equal to 0, you get -2. When you solve that term,
Yep.
the term that cancels, you set it equals 0. There would literally be an open circle right there, just hole.
So there's still
No
an
graph.
asymptote?
There's no asymptote. Well, there now. The x plus 1 did not cancel. So is there an asymptote there? Yeah. And where does that equal 0? That equals 0 at -1. So therefore, you would have a vertical asymptote at x equals -1. but you would just have a hole in the graph.
Wait, so how come that one is negative 2 and the other one?
Here, let me redraw, that would be better.
Hey, you're at 15 minutes.
Okay, thank you, I'll get it in a sec. So, yeah, because I do know this one has a vertical at -1, so this one's got an asymptote rolling here. It's going to have a horizontal edge.
How come that one is a positive 2 instead of negative 2?
And it's going to go... And at -2, wherever -2 lands, I didn't plot it exactly, wherever -2 is, there's a hole in the graph.
So it just skips over -2.
It just skips over -2. If you are on your calculator doing trace and just tracing along the graph, when you get to -2, there'll just be no coordinate or point there. It's just not there. It's literally a hole in the graph. It's very weird. You can't really shade the hole, no. It's just there. Okay, so this one would have a vertical, it would have a hole. Does it have a horizontal? Okay, how did we check for horizontals? We use the greatest power term. So I would look up there and I would go, oh, I had x squared over x squared, which reduces to 1. So therefore my horizontal asymptote is the asymptote y = 1.
16 minutes.
Thank you.